Hello, today we're going to talk about Chapter 4, Lesson 6, and that is constructing functions. We've done a lot of this in the last couple sections. The more versatile you can be in interpreting this data, because there are many ways to attack each of these problems. So kind of go with what you see, trust that, and just continue through the problem. You'll probably arrive at the same answer as everybody else, so we don't have to do it the same way. In one of the examples, I try to show you a few different ways, but there are a lot of different routes to take. So again, trust your gut. You know how to find slope from a table, from a graph, from a set of ordered pairs. We just have to kind of use what you see first, and I'll try to give you some suggestions along the way. So let's get started. So finding the rate of change, we know we can use 2 points from a graph to do that. We can see the graph and go rise over run to find the rate of change or the slope. We can plug them into the slope formula, and we're going to need to know this today. So if you don't have that in your memory bank, make sure you write that down right now. You're probably going to use it a lot. Okay? And then finding the initial value, we've talked about a few different ways to do that. The initial value is the y-intercept. So you can look at where a line crosses the y-axis. You may have to extend your line, and then we can look at a table of values and find the y-intercept, and I'm going to show you a way to do it algebraically today as well. So again, lots of different ways to see a problem today. So let's take a look at the first one. In this one, they give us a graph, all right, and let's just figure out what we have to do first. So the pottery studio charges a certain amount per hour plus a firing fee to fire the pottery. The graph shows the total cost of using the studio for different amounts of time. Find and interpret the rate of change, that's the slope of our line, and the initial value, that's the y-intercept. So we can look right at it, and we can say that this is probably $10, so that's their firing fee. And then we can try to figure out the rate of change. I think we're getting pretty good at that, so I'm going to just review how to find the rate of change using the slope formula. So the first thing I want to do is we want to think y equals mx plus b, all right, where m is our slope, in this case it's the cost per hour, and b is that firing fee. So we can see it, the y-intercept looks to be about 10, it's halfway between 0 and 20. We're going to find the slope by finding 2 good points. So I see that 2 hours is an even $40, and 6 hours is an even 100. Okay, so I just found 2 perfect points, so I'm not doing any guesstimating. All right, I'm going to take those points and put them into the slope formula. So my y's were $100 and $40, and my hours, my x's, were 6 hours and 2 hours. So 100 minus 40 is 60, and 6 minus 4 is 2. Sorry, 6 minus 2 is 4. There we go. And then 60 divided by 4 is 15. Okay? So that's $15 per hour to use this studio. So that's that. And then our equation for this is going to be y equals $15 per hour plus the $10 per firing fee, so just a $10 upfront cost. And if you're getting really comfortable, you can say the cost as a function of hours is 15h plus 10. Okay, again, interpreting $15 per hour plus the $10 firing fee. All right, in example 2, we're going to be given the rate of change or enough information to find it, and that's going to be kind of what we did in that last slide using the slope formula, or making a table, and a point on the line. We're going to plug those values into the slope-intercept formula. So this is kind of where I'm going to show you the algebraic way to do it, which is kind of handy. It takes some of the thinking out once you get comfortable with it. And so, again, we got to know y equals mx plus b. All right. We're going to know a point, so we're going to use an x and a y. We're actually going to know quite a few points. We just need one of them. We're going to either know the slope or we're going to figure it out, and then we're going to solve this equation for b, which really just means we're going to add or subtract that m times x value, whatever it is, from both sides of the equation to get b, and that will tell us what the initial value is. Okay? So here's an example. Each week, Sam works the same number of hours. Her first week included an orientation, so that first week there was like extra work, so she had to sit in a meeting and probably watch videos and stuff. The total number of hours that she worked the second, third, and fourth weeks was 20. So that was all, 4 weeks, 20 hours. And then both weeks was 20 hours. All 3 weeks together was 28, and then the fourth week together was 36. So assume the relationship is linear, so she's working the same amount every time, and find and interpret the rate of change in the initial value. So what I kind of thought, instead of doing just a straight algebraic way to do this, I kind of thought of this as a table. So we know after 2 hours she had worked 20, after 2 weeks she worked 20 hours, 3 weeks 28, and 4 weeks she worked 36. Okay? So we can find the rate of change by looking at the hours column in our chart. So what I mean by that is, like if I go from here to here, that's adding 8. Okay? And then the same thing, 28 to 36 is also adding 8. So that's my rate of change. Okay? We don't have to do it this way. I just wanted to show you another way that we worked out in the last couple of weeks to do this. All right? So we can find the initial value by working backwards until we get to week 0. So remember that the 0 week, she hasn't worked anything but that orientation. If we work backwards in this chart, that's why I left those blanks, we can find the y-intercept. So kind of thinking, what would I have to add 8 to get 20? That value would be 12. And if I kind of thought the same idea here, what do I have to add to 8 to get 12? Sorry, that value would be 4. All right, so that is her initial orientation hours was 4 hours, and she works about 8 hours a week. So that is the answer to our problem. All right, but let's do it algebraically as well. So we figured out the rate of change by using this table. It was 8, so that's my slope. And then notice I colored these two values they gave us. The first, the smallest values, 2 weeks was 20 hours, green and red. Well, I'm going to put the red value for the y, okay? And I'm going to put the green weeks for x, okay? And that looks like that. I make this multiplication. 8 times 2 is 16, okay? And I'm going to subtract 16 from both sides. Remember, that's subtracting that mx value like I had on the other slide. And 20 minus 16 is 4. So, again, it kind of proves how we get this initial value by working backwards. We can do it algebraically as well. All right. Remember, if you're doing it this way, you really won't have to make this table at all. I just wanted to show you 2 different ways. And then to write out what's going on. Sam works 8 hours each week, and her training was 4 hours long. So that's example 2. All right. In example 3, we're going to pick 2 points from the table and find the slope using the slope formula. All right. I think in the next table, it's kind of far away to work back to 0. Like this is probably a little more efficient. We're going to plug a point and the slope in, so just like I did algebraically in slide 2, okay, or example 2. And then we're going to solve for b. All right. Then we have to rewrite the equation in slope-intercept form. I'll fix that. And plug m and b back into the equation. Oh, I can't do that. Yeah, we're okay. There we go. So, here's our table. So, we have a table of the weight of a puppy in 4 weeks, 5, and 6 weeks, and 7 weeks. So, 4 weeks, the puppy weighed 17, and then 5 weighed 20, 23, and 26. So we're going to find and interpret the rate of change, the initial value. So again, we could kind of do this idea of, well, we add 3 every time, and that's the rate of change. Okay, we can do that. All right. But then we're not really practicing our algebra. All right, and then if we work backwards, we could figure out this puppy's initial weight, but we'd have to work backwards 3 times, okay? Which isn't overly difficult, but I do want to show you another way. So, and you can see the answer. I forgot to have that fly in. Let me make that fly in really quick. There we go. So, I took just the first 2 points, so the y value, 20 minus 17, y2 minus y1, 20 minus 17, divided by x2 minus x1, and I colored these because I'm going to put them into the formula again. 5 minus 4. That gives me 3 divided by 1, which is 3. I made that red for the sake of the formula. So now I'm going to use the formula y equals mx plus b. And I chose the 20 and 5 because 17 is just not a number I like to work with. I think I'd be rather subtracting in values of either like, factors of 5 or multiples of 5 and 20. I think I'd rather deal with those than this 4 and 17. So that's why I chose that. Y is 20, so y equals m. My slope is 3, and my x value is 5, plus b. So we're going to solve this for b. I got to clean this up first. 3 times 5 is 15. I'm going to subtract 15 from both sides. 20 minus 15 is 5. So my initial value is 5. So I can say that the puppy gains 3 pounds each week and has an initial weight or birth weight of 5 pounds. And if I had to write that equation, it would look like this. Y equals, let's see, the rate of change was 3x, and then the initial weight was 5. The y-intercept was 5. So if I had to make an equation, they asked me for that information, that would be the equation I'm trying to make. All right. So again, I don't put in y and x. I just use that particular week to be able to figure out the initial value, the y-intercept, and then I write the equation for every week. So I don't want to have the 20 in there still and the 5 in there. I just want a general equation to figure out any week that this puppy is growing. So what we're going to do then is I want you to work on the goddets, A, B, and C. It starts on page 320. I think it's they just kind of go one after each page. So A, B, and C, work on those. And then I want you to work on the guided practice 1 through 4 and the independent practice 1 through 7. Now, number 7 is a problem I really like. I think it's important to understand what's happening there. So if you do it correctly, and I'll be the judge of that, you can use that problem to replace any missing assignment you have from this marking period. So I'll pick that up separately from these. So maybe put number 7 on a separate sheet of paper, half sheet. Again, you can turn that in to me to replace any missing assignment that you've had. So I hope this video helps, and I'll see you guys tomorrow.